In this video here, we're going to take a look at second order non-homogeneous differential equations. So we now want to examine how to solve second order non-homogeneous differential equations, and these are second order differential equations of this form here. So notice then they're very similar to what we saw in the previous video for homogeneous differential equations. The difference now is the right hand side here is expressed as some function of x. Okay? So the first thing that we need to do here to solve a second order differential equation of this form is find the general solution of the corresponding homogeneous differential equation, okay, of this form here. And again, you should recognize this from the previous video. And this is known as the complementary function. It's often just shortened to c dot f dot, okay, just meaning the complementary function. We must then find a particular integral, again, shortened to p dot I dot, so just the particular integral here. And this is a function which satisfies the differential equation. So the form of the particular integral is dependent on f of x. So let's have a look then at some particular integrals you might find useful to try. So as we mentioned then on the previous page, the particular integral is dependent on the form of f of x. Now the table below that you can see here will give you examples to try for the particular integral based on the form of f of x. So in the left-hand column here, we have the form of f of x, and then in the right-hand column here, we have the form of the particular integral. Now, I'm not going to go into a massive amount of detail here and explain each individual row, but for example then, if the form of f of x here is just a constant, so for example it's just p, then the form of our particular integral here that we would try would be lambda, okay? As another example here, if the form of f of x is p plus qx, then the form of the particular integral here that we would try would be lambda plus mu x, okay? And as I said then, I won't go through each row individually here, but what I would say is please do make a note of this table, okay? And once we obtain our particular integral, we can then go on to form the general solution here, which is simply the sum of the complementary function and also the particular integral. So in that case then, y here, our general solution is equal to the complementary function plus the particular integral. Now before we work through an example together here then for second order non-homogeneous differential equations, there is just one thing that we do need to watch out for. So to finish with here then, we need to be careful if the standard form of the particular integral contains terms which form part of the complementary function. Now, if this is the case, what we need to do here then is modify our particular integral so that no two terms in the general solution have the same form. So for example then, this situation occurs when f of x is of the form pe to the kx and k is one of the roots of the auxiliary equation. In this situation, we could try a particular integral of the form lambda x e to the kx here, okay? And if one of the roots of the auxiliary equation is 0, then the complementary function will contain a constant term. So if f of x is a polynomial, you will need to multiply its particular integral by x to make sure that the particular integral does not contain a constant term as well. So like we said then, this is something that you do need to be careful of, and just check this as you work through any question here on second order non-homogeneous differential equations. So to finish with here then, let's just take a look at a practice question together. So let's just have a go then at this one practice question here for second order non-homogeneous differential equations. So a bit of a mouthful there, but we got there. So all I want to do here is just solve this differential equation, right? We want to find the general solution. Now, as I can see straight away here, this is a second order non-homogeneous differential equation where f of x here is equal to 27x. So let's just make a note then. The general solution here, so the general solution, and this is for y by the way. So the general solution here is y is equal to the complementary function at CF plus the particular integral, and that's p dot I. Okay, so the general solution here, y is equal to the complementary function plus the particular integral. Okay, so for questions like this, I like to break this down into two different parts here. Part 1 is finding the complementary function, And then part 2 is finding the particular integral. Okay, so let's just start here then by finding the complementary function. So for the complementary function, that's c dot f here. Well, to find the complementary function here, the first thing that we require is the auxiliary equation. So we require the auxiliary equation here. So the auxiliary equation then would be m squared plus 6m plus 9 is equal to 0. So like we just said, then we get m squared plus 6m plus 9 is equal to 0, right? What we want to do here then is solve this quadratic equation for m. Now, what I can see here by inspection is this will factorize. I get m plus 3 all squared. And this here is equal to 0. And what I can see here then is we have a solution of m is equal to minus 3. Okay? And at this point here then, we can now deduce the complementary function. So the complementary function is y is equal to a e to the minus 3x plus bx e to the minus 3x there. Okay, so that gives us the first part here, that is the complementary function. So now then, let's have a go at finding the particular integral. So this is basically part 2 of the question here. So for the particular integral here then, that's p dot I. Okay, and this is where things start to get a little bit more complicated here then in solving this second order non-homogeneous differential equation. So where do we begin here? Well, to begin with here, as we can see then, let me just do it above here. F of x is equal to 27x. So this is just the same here as 0 plus 27x. So it's of the form then p plus qx. So what I'm going to try here, so we're going to try then y is equal to lambda plus mu x. Okay, so let's just make a note of that here. So let's just try then y is equal to lambda plus mu x. Okay, now let's just differentiate here then with respect to x. So dy by dx here. So dy by dx here then, nice and straightforward, that's simply mu. And we also require here the second derivative. So for the second derivative here then, well again, nice and straightforward, that is simply 0. Okay? What I want to do here then is take dy by dx and the second derivative here and substitute those into this equation here. Let's just call this equation 1. Okay? So if we do that here then, I've got the second derivative, which is 0. So I get 0 plus 6 lots of dy by dx here, which is mu. We get plus 6 mu. And then I've got 9y here. So y is lambda plus mu x. So I get 9 lots of that. So plus 9 lots of lambda plus mu x. Okay. And all of this here then is equal to 27x. So let's just expand out here then this bracket. So I've got 0 plus 6 mu. So I've just got 6 mu. I've then got 9 lambda. So 9 lambda. And then 9 times mu x here. I get plus 9 mu x there. Okay. And this here then is equal to 27x. So what I can see here then is we have two constant terms, right? I've got 6 mu and 9 lambda. So let's just group those together. I've got 6 mu and 9 lambda, like so. I've also got this term here then for x, so 9 mu x there. Okay, and again, all of this here is equal to 27x. Now, as we noted up here then, the constant term is 0. So I've got 6 mu plus 9 lambda is equal to 0. So 6 mu plus 9 lambda is equal to 0. And let's just compare coefficients as well here for the x term. So in that case, then what we get here is 9 mu. So my coefficient here is 9 mu is equal to 27. Okay. So what we need to do here then is just solve for mu, right? So let's just divide both sides by 9 then. And as we can see here, mu is equal to 3. Okay. And once we obtain this solution here for mu, right, we can solve this equation here. So we just do that underneath then. 6 mu is 6 times 3, so that's 18. Plus 9 lambda is equal to 0. In that case, then 9 lambda is equal to minus 18. And then as we can see here, lambda is equal to minus 2. Okay, so as we can see here then, let's just continue up here at the top. So our particular integral then, here is, so it's y is equal to lambda plus mu x. So y is equal to lambda, which we just evaluated as minus 2. So minus 2 plus mu x, where mu here is 3. So minus 2 plus 3x there, like so. And then at this point here, the question is pretty much complete, right? All we need to do then is just give the general solution here as the sum of the complementary function and the particular integral. Okay. So therefore, the general solution then, let's just make a note here. The general solution is y is equal to, so our complementary function here is the following. We get ae to the minus 3x plus bx e to the minus 3x plus our particular integral here, which is minus 2 and plus 3x there. Okay, as we can see here then, this here is our general solution. And there we go then. So as you can see here, obtaining the general solution is quite a lengthy process, and it is very easy to make a mistake as you work through these questions. So do take your time and just be very careful as you work through questions here on second order non-homogeneous differential equations. But there we have it then. That gives the solution to the one practice question for this video here. And that brings us to the end then of this video here on second order non-homogeneous differential equations.